All right, one last thing in this atomic quantum unit, and that last thing is lasers. Okay, and you might not realize that lasers are actually tied into atomic and quantum, but they are. And they go all the way back to 1917, and it was Albert Einstein that figured out how a laser could work. He couldn't make one then. It took another 42, 43 more years, but he was the one who figured it out. So first we have to go back and we have to realize that when an atom in its ground state is excited, then a photon is absorbed and the electron jumps up to a higher energy level. Okay? And this electron's going to stay up here for a bit, but it's eventually going to fall back down, and when it falls back down to its original level, it's going to emit the exact same photon that it took in. Okay? So that's nothing new. That's what we've been talking about since Bohr, Rutherford. But so what Einstein began to imagine was what would happen if when this atom that had the electron excited into a higher state, what would happen if we were to strike that electron with a photon that's exactly the same as the original photon absorbed? Okay, so the atom absorbs the photon, the electron jumps up, and now, while it's still up there, before it falls back down, what if we were to hit this atom with a photon exactly like the one that it just absorbed? What he imagined would happen, and what we now know would happen, is that when you strike the atom with a photon that's identical, that this electron will fall back down, and the little photon dude that it had absorbed will be given off. And the guy that struck it will also still be there. Okay, and so now both of these will leave the atom, and so he said, okay, so then if these two struck two other atoms that had been excited, then those two would give off photons, so then you would have 4, and then if they struck 4 more, there would be 8, and then 16, and then 32, and 64, and before a blink of an eye, you would have an avalanche of photons that would all be coherent, that would all be in phase, that they would all have the same wavelength and be in step or in phase with each other. And he thought if you could then somehow, take all those photons that were being emitted, that were in phase, this avalanche, you could have a nice beam of photons. Okay, now to do this, he realized, and when you strike an atom with a photon that's the same as the one it has already absorbed, it's called stimulated emission, meaning you are forcing it to emit, right? Stimulated. It wouldn't actually do it on its own, but you're forcing it to do right then. So stimulated emission. Now Einstein realized there were two conditions that were necessary for this to happen, and they were the two that in 1917 he was not able to do. The two conditions are, one of them, you need atoms in an excited state. That one he could handle. The one that took a while to be able to do effectively was that the photons must be collected. The photons that were being given off, the photons must be collected and contained so that they could be used to strike other atoms. It contained to be used to strike other electrons. Okay? And that one was the tougher challenge. So it was 1959, 1960 that the first laser came about. And it was the guy who gets credit for it is Theodore Maiman. Now I say the guy who gets credit for it because undoubtedly there were other people working at the same time. This guy I would think is probably the one that had the patent. Okay, so he was able to create a device, invent a device that was able to to match Einstein's two necessary conditions, and he called that device a laser. Okay, now not by accident, because laser stands for light, L, amplification, A, by stimulated, S, I think I just crossed the L instead of the T there, stimulated emission, E, of radiation. Okay, so that's where the word laser comes from, R. All right, and an atom, when it's excited like that and struck with a photon that matches it, we say that it lasers, that there's light amplification by stimulated emission. Okay, so a laser, it's the beam of radiation is from atoms lasing. And usually, so the first step is you have to get these atoms excited, and we do that by running an electrical current through them. So it might be batteries or whatever. Most common lasers are probably helium-neon, and the helium atoms are excited, and then they collide with the neon atoms, exciting them, and then it's the neon atoms that laze. When the laser was first created, it was the best line in the world. When it was first invented, people were like, wow, this is really cool, this is really neat, what do we use it for? And so the best line ever with lasers, they said it was a solution looking for a problem. In other words, like, what are we supposed to use this for? And we'll get to its uses in a second. But some of the characteristics of a laser is, one, that it's directional. Meaning that if you take a laser and you shine it on the back wall, the dot of light that leaves the laser is exactly the same size as the dot of light that strikes the back wall. It doesn't spread out the way like a flashlight light would. Okay, so it's directional. Lasers are always monochromatic, and I know you know what that means. Mono is one, chromatic is color. Okay, so one color, one wavelength. The photons that are given off are always the same wavelength. It's intense. Remember, it's an avalanche of photons. So it's a very intense, high intensity, a lot of photons, okay? Very intense light or bright. And then the last one, coherent, meaning that all those photons are in phase with each other. Remember that photons are considered waves as well, and so when waves are in phase, the troughs and the crests match up. Okay, unfortunately, lasers are really inefficient. Early ones were about 1% efficient. So the amount of electricity put into them to excite the atom compared to the amount that we get out in the avalanche of photons is not really very efficient, but I'm sure people are working on it. So the solution that was looking for a problem, where do we use lasers today? Surveyors use them when they're trying to like draw straight lines or make straight paths. When they were building the bridge between New Brunswick and Prince Edward Island, they would have used a laser to make sure they had the two ends lined up, because there'd be nothing worth, when you're building from either side, to not meet in the middle. Fiber optics, so all of us at home right now using our internet, fiber optics, the light signal sent through those fiber optical tubes, the fiber ops is a laser. Another spot would be in holograms. If you've ever seen a three-dimensional image, that's a laser. Laser eye surgery, and all types of surgery in medicine now. Rather than using a knife and other surgeries, in the eye surgery they use the laser to burn like the cataracts off, and other surgeries they use it as a cutting. In industries to cut, and like steel and things. Electronics, nuclear fusion, there's all kinds of uses for lasers, and it's only when we understood what was happening in the spectra that we could create them.